first problem written here. We have the integral of x cubed times sine x dx. So just by looking at this, we can go through a mental checklist, right? We can't do integration using u sub because it's too complex and there's nothing that cancels out. We can't do trig identities because we only have one piece of trig in the functions in the integral, so we can't cancel out anything either. We obviously can't do division, partial fraction. So what we're left with is integrating by parts. So what we're going to do, I wrote the formula here. We have a u du, and then we have a v and a dv. So we're going to go through Lipit. We have an x cubed, so that would be our u, because that's a polynomial. And then our dv would be sine x dx. And du would be 3x squared dx. And v would be negative cosine of x, because the derivative of negative cosine x is sine of x. So now we're just going to write it out. So we have u, which is x cubed, times negative cosine of x, minus the integral of v, negative cosine x. Sorry, this looks like, okay. Negative cosine x times du, so times 3x squared dx. And once again, we're going to have to use integration by parts because we can't use any other form of substitution, any other integration technique. And we're going to have to keep doing this until the x drops out. So again, u equals 3x squared, du is equal to 6x dx. And then v and dv. dv is going to be negative cosine of x dx, and then v is going to be negative sine of x. Okay, so now we're just going to repeat this, except we have to drag this down. So we have negative x cubed cosine x. I just brought the negative out. And then we have minus. And then we have to repeat the process. So minus. So we're going to do u 3x squared times negative sine of x. And then we're going to do minus the integral of negative sine 6 of x dx. Right? Well, that's the dx only applies here. So now we're going to rewrite. We have negative x cosine x minus 3x squared sine x plus negative sine x, what really big, negative sine x 6x. This became positive because that distributed there. dx. Okay, we're gonna have to do this one more time and then we'll be done. So because the x will drop out. So again, u equals 6x, du equals 6 dx. dv is equal to negative sine of x dx, and v will equal cosine of x now. So we made like a full loop in the trig, kind of. So now let's write all of this, bring it down here. So we have negative x cubed cosine of x minus 3x squared sine of x. And then finally we have plus, and we're going to do this part. So 6x cosine x uv minus 6. And then I'm going to take the cosine x dx. So it's v times du, but I'm gonna take the 6 out. So yeah. So now we can do this because we don't have, oh, that was terrible. Hold on. Ah, I can't do this on iPad. Okay. So now cosine x, we know that that's just going to be the integral of cosine x is just sine x. So we can full out write the complete answer now. So negative x cubed cosine x minus 3x squared sine of x plus 6x cosine of x minus, and then bring the 6 out, sine of x plus c. And that's the complete answer. So yes. So this is problem number 2. We have 5x plus 2 all over 2x squared plus x minus 1. And what we can see is that the degree of the top is less than the degree of the bottom. So that means that we can use partial fraction decomposition, but first we would have to ensure that the bottom can be broken up. It can be factored. So what we're going to do, I forgot to draw the integral. Okay. So if we want to factor this, the bottom, it would be 2x minus 1, and then it would be x plus 1. So this means we can do partial fraction decomposition, so that's what we're going to do. So we have 5x plus 2, I'm just rewriting it, 2x minus 1, x plus 1, gonna equal a over 2x minus 1 plus b over x plus 1. And now we're gonna multiply the whole thing by the bottom, so 2x minus 1 and x plus 1. So this leaves us with 5x plus 2 equals a. These are going to cancel out. A x plus 1 plus b. These cancel out. So we're going to do 2x minus 1. Okay. So first, now we're going to have to set the x's in both multiplied by a and b equal to 0. So first we're going to do x is equal to negative 1. So we have 5 negative 1 plus 2 equals a, negative 1 plus 1 plus b, negative 2 minus 1. So this is going to drop out. We have negative 5 plus 2, which is negative 3, equals b times negative 3. And then we're going to simplify that, and we get b equals 1. So now we know what b is. Then we have to use this again, and this time we're going to cancel out b. 5x plus 2 equals a x plus 1 plus b 2x minus 1. And now x is going to equal 1/2. 5 over 2 plus 2 equals a 1/2 plus 1 plus b 1 minus 1. So I'm not very good with fractions, so give me a second. I should be quicker at this. It's 9 over 2 equals a, and then that's going to be 3 over 2, right? I don't know. Plus b times 0. So now we have 9 over 2 equals a times 3 over 2. And we divide by 3 over 2, we divide by 3 over 2. And then we get cancel, cancel. It's going to be a is equal to 3. So now we can rewrite. We have a and b. So we're going to go here. Actually, we'll go here. So now we have rewrite this. 5x plus 2 all over 2x squared plus x minus 1 is equal to the integral. So we have a, which is 3. We have 3 over 2x minus 1 plus b, which is 1, is going to be 1 over x plus 1. And then if you want to solve this, all you have to do is natural log 2x minus 1 plus natural log of x plus 1 plus c. And yeah, that's I made a mistake. I forgot to take the 3 out. So it would be like that. So the actual answer is 3 natural log of 2x minus 1 plus natural log of x plus 1 plus c. There. So I'm skipping to number 5 because I'm a bit confused on the other two. But for this integral, we have the integral of x squared inverse tan x dx. So looking at this, we can't do substitution because nothing inside the integrand can cancel each other out. We can't do trig sub. We can't do numerical, and we can't really do anything. So the only thing we have to do is integration by parts. So in this case, u is going to be following Lipit. U is going to be inverse tan. So we're going to write arctan of x for u. And then du is going to be the law for the derivative of arctan, which is 1 over x squared plus 1 dx. And then dv is going to be x squared dx. And then v is going to be x cubed divided by 3. So now we have that. We can do, it's going to be uv minus v du, right? So we're going to do arctan of x times v, which is x cubed over 3, minus the integral of x cubed over 3 times du, which is going to be 1 over x squared plus 1 dx. Okay. So looking at this, let me rewrite this. So we have arctan x times x cubed over 3 minus. So over here, I'm going to take out 1/3 from the integral. So then it's just going to be x cubed times, so we're going to combine the fractions, x cubed over x squared plus 1 dx. And then I actually like this because the powers in the numerator and denominator are different. The numerator and the denominator have different powers, so I can work with this in a way. So I think I'm going to try long division. So it's going to be really short, but you know, it's okay. Okay. So that's going to be x. It's going to be x cubed plus x. Change the sign. So we have negative x. So that's the remainder. So it's going to be x minus x over x squared plus 1. So now we can rewrite that. I'm only going to rewrite the integral. So it's going to be the integral of x minus x over x squared plus 1. And this is straightforward. So the integral of x is going to be x squared over 2, right? So let me arctan x times, I'm just rewriting everything, minus 1/3. And then I'm going to write times 1/3 is going to stay there, but we're going to add squared over 2. And then minus again 1/3. It still applies to the rest. Minus 1/3 x over x squared plus 1. I'm like running out of space. So let's focus on the integral here. So I actually can do u sub because the derivative of this is inside the integrand. So let's try that. We're going to have u equals x squared plus 1, du is equal to 2x. So it's going to look like x over u times du over 2x. So this is going to cancel out, and we're going to have 1 over 2 outside. So it's going to be 1/2 the integral. The x is canceled out, so it's 1 over u du. And then if we plug u back in and we do natural log, we can get 1/2 natural log, and u was x squared plus 1. And then now we just have to add the rest. Arctan of x cubed to the 3 minus x squared all over 6. I combine that. And then minus 1/6 natural log of x squared plus 1 plus c. I made it 6 because I have to distribute the 1/3 here as well. And yeah, I think that's right. Problem number 4. I'm going in backwards order now because these last two were a bit confusing, but I think I got them now. So this is an integral of 1 over 1 minus cosine of x dx. Now we can see that we do have a possible trig rule or law that could occur here, but we don't have anything like if we did u sub for 1 minus cosine of x, we can't even, there's nothing in the numerator we could cancel out with that. So we can't do u sub. So what we have to do is manipulate this integral to create more trig inside of it so we can start canceling things out. So what I'm going to do 1 minus 1 over cosine x. I'm going to multiply the top and bottom by 1 plus cosine of x dx. So we're going to get the integral of 1 plus cosine of x. And then if you multiply those two together, you're going to get 1 minus cosine squared of x. Now we can see here that we have a trig rule because sine squared x plus cosine squared x is equal to 1. So sine squared x is equal to 1 minus cosine squared x. So we can add that in there. So I'm going to rewrite it as 1 plus cosine, oh, that was terrible, 1 plus cosine of x all over sine squared x dx. Okay. So now here's a good thing, we have the denominator, which is a power higher than the numerator, and we have trig in both the numerator and the denominator, so we can start canceling stuff out. But first I'm going to separate the fractions to make things easier. We're going to separate the numerator, so 1 over sine squared x dx plus cosine of x sine 2x dx. Okay, this one is simple trig. We know that 1 over sine is equal to cosecant. So now we have cosecant squared x dx plus, and then this one here, it's basically 1 over sine times cosine over sine. Cosine over sine is cotangent, and then 1 over sine is again cosecant. So now we just have the integral of cosecant times cotangent x dx. And then these are just trig rules that we've learned. So the integral of cosine squared x dx is going to be negative cotangent x. And then this is going to simplify to negative cosecant x plus c. So yeah, the antiderivative of cosecant squared x is negative cotangent, and then that's going to simplify to negative cosecant x. So yeah, that should be it. Confusing for me, and I just now understood it. I had to search some methods up online to do a part of this integral. So now I'm gonna attempt it. So we have x cubed, integral of x cubed over minus 1 over x cubed plus x dx. And this is not good because the powers are equal. We can't cancel anything out. We can't do u sub. So the only option we have is to rewrite this. Oh, that's me practicing. So what we're going to do is we're going to rewrite this so that later we can use one of the techniques. So we're going to keep that. We're going to keep the same denominator. All I'm going to do is add plus x plus 1 and minus x plus 1. And this is legal in math because these two cancel each other out. I'm not adding a random number or x out of nowhere. These two will equal 0, so it's completely legal to do. And then I'm going to separate the integral. So I'm going to do x cubed minus 1 plus x plus 1 minus x plus 1 all over x cubed plus x. So I separated the numerator. And then from this, we can see negative 1 and positive 1 canceled out. And now we have x cubed plus x over x cubed plus x. So that's great because now that equals 1. And that's very easy. But now we have this as the rest, dx. Let me write dx. Okay. So now we can write that this is equal to x minus the integral of x plus 1 all over x cubed plus x dx. Now from here, this is great because now we have a higher power in the denominator, so we can somehow cancel stuff out. We can work with this. So what I'm going to do is partial fraction decomposition. Actually, I'm going to focus only on the integral here. So I'm going to factor out x from the numerator. So we have x squared plus 1 dx. And from here we can do it. So a over x, and then this is the bit I had to learn online. So since this isn't linear in comparison to x, this isn't linear, right? So that means we can't just have b. We're gonna have to add a constant and mimic the function in the denominator. So we're gonna have to write bx plus c. I didn't know that. I had to learn that online. So now we're gonna do the same old process, times x squared plus 1. So now we have x plus 1 is equal to a times x squared plus 1 plus bx plus c times x. That's a c. Okay. So now we have x plus 1. We're just going to simplify this out. Ax squared plus a plus bx squared plus c x. And now we're going to write this. This is so lopsided. We're going to write this in correct order. So x plus 1 is equal to ax squared plus bx squared plus cx plus a. And then I can just group this together and do a plus b x squared plus cx plus a. And then from here we can't, since we have three variables in here, we have a, b, and c. So we're gonna follow, this is another thing I learned online, is that like in this equation and in here, the coefficients, since the two polynomials are equal, the coefficients also match up. So this means that x here is equal to cx. So that means that c is equal to 1. And then we also know that a is equal to 1 because a is a constant, and this is a constant here, so a is equal to 1. And then we have a plus b. There's no equivalent to a plus b here, so we can just say there's 0 because it doesn't exist. It's like that. So we have a plus b is equal to 0. So this is now a system of equations. Let me rewrite this. 1 is equal to a, 1 is equal to c, 0 is equal to a plus b. So now we just have 0 is equal to 1 plus b, and now we know b is equal to -1. So now we have a, b, and c. So now we just plug it in back into that. I'm going to draw it down here. So now we know that the integral of x plus 1 all over x squared plus 1 dx is going to equal, so a is 1, so we're going to do 1 over x, right, plus bx plus c. So b is -1, so negative x plus c, c is 1, so negative x plus 1 all over x squared plus 1. So now we have that. And that is great because this is really easy and this can be made easy. So I'm just going to rewrite everything. This is very messy, I'm sorry. So we have x minus the integral. I need to make it smaller. X minus the integral of 1 over x plus negative x plus 1 all over x squared plus 1 dx. Okay, so x minus this is just natural log of x. So now we only have the integral of negative x plus 1 all over x squared plus 1 dx. And now I'm going to separate this fraction over here. So, am I doing this right? Yes, I am doing this right. Okay. So now we're going to do x minus natural log of x plus the integral of negative x all over x squared plus 1 plus 1 over x squared plus 1 dx. And then this is great because we know this is arctan, and then we can do u sub for this. So x minus natural log of x plus, let's do the u sub. So u is equal to x squared plus 1, du is equal to 2x dx. So that's going to become negative x all over x squared plus, negative x over u times du over 2x. So that's going to cancel out. So now we're going to have, let me just do this too. So this is just arctan, right? Because it's x squared plus 1. So this is going to become 1/2 1 over u. So that's just going to become natural log, and then this is arctan. So let me just rewrite everything. X minus natural log of x minus 1/2 natural log of the u, which is x squared plus 1. And then we're going to do arctan. So it's only, this is very straightforward. It's just x squared plus 1. So it's going to be plus arctan of x and plus c. So yes, I'm sorry, it's very messy, but I think that's the correct answer. I did, just to clarify, this was u sub, and this is arctan. and I got these from before. So yeah.